My name is Aliza Pakahar, and today I would like to talk about discrete probability functions. The objectives of today's lecture is definition of discrete variable, and then I would like to tell about uniform distribution, and then binomal distribution, and of course expected value for each of the distributions that I will tell you. But first of all, what is the probability mass function? A function representing the relative distribution of the frequency of a discrete random variable. But what is a discrete random variable? If you remember from the last tours, we talked about different type of variables, and you can see through to that PowerPoint, that slide. For example, family size, that it is a number of dependents reported on tax return. It is a discrete variable and finite. For another example, we have distance from home to store, and it is a continuous variable. And for the other example of our discrete variable, we can say about in production line the number of defect items that we can pick up from the production line. And this is a discrete variable but infinite, because production line is infinite. The main condition which applied in any function is that the sum of all the probability should be equal to 1. And as you can see in this slide, probability P1 plus P2, etc. Pn should be equal to 1. With applying this condition, we can realize that what is exactly the probability function. For example, look at this example. I would like to ask you to help me to solve and find what is the C in this example. Please join as a group to each other and try to solve the problem. Given that the probability function of a discrete random, sorry, I think it's happened for the laptop. I don't know what happened. Sometimes it happens normal, you know, the technology sometimes works, sometimes doesn't work. But okay, no problem. We can just have a look and work with the paper, your paper. Please take a paper. And the question is, we have, oh, yes, just after, yes, reset of the computer, we can again come back to the slides. But the question is, the function that I need to implement that, it is Px, C, x power 2, and x is 0, 1, 2, and 3. What is the C if it is a probability function? You have 2 minutes to solve this problem. It's so easy. Do you have any idea? It's just for start, apply in some sort of this table, do x and then Px. 0, 1, 2, and 3, like this, and then apply to the function. And for example, 0 is, the result is 0. For 1 multiply C. For 2 power 2 multiply C is 4C and 9C. Okay, and then what about applying the condition? We should add to each other that probability and equal to 1. Okay?
So, sir, the domain of the function is the real numbers, or?
Yeah, this is discrete numbers.
Oh, discrete numbers.
Yes.
Okay.
X is 0, 1, 2, and 3.
Okay.
Okay?
Okay.
With applying that,
Okay.
0 plus 1C plus 4C plus 9C and is equal 1. Therefore, here C. Who of you can find C? it's 1 over 14. Yes.
14.
Yes.
Yeah.
So therefore, if we consider px 114 x power 2, this is a probability mass function. Okay? Suppose that this time we haven't any break in technology. I hope. But right now, this is the time for introducing you uniform distribution. I'm sure that all of you have sometimes play with dice. As you know, each dice has 6 faces. When you throw the dice, the probability of having, for example, 1/4, what's that? 1 over 6, because we have 6 situations, and one of them is the face that is at the top. And for another example, if you draw the dice, and what is the probability of having a 4? 1 over 6. Because of that, for all of the situation, you have only one probability, 1 over 6. And because of that, we say this is a uniform distribution. Okay? Is that clear? Now, unfortunately, we haven't any technology. It's cracked down, but I try to fill out the material. The other thing that I should tell you is about the expected value, and I want to implement expected value with a uniform distribution. For drawing dice, what is the expected value for the probability? We realize that x and px 1, 2, 3, 4, and 5, and 6. And for each one, 1 over 6, 1 over 6, and 1 over 6, etc. Alright?
Okay.
What's your idea about the expected value? It is the mean or average of the
this,
dice.
yeah.
For applying this formula, expected value is x multiplied kx. Okay? Therefore, 1 multiply 1 over 6, 2 multiply 1 over 6, and so on. The mean of a dice is 3.5. Okay? This is the expected value. Okay, it's gonna go. Okay? I think because of many problems in technology, we cannot continue and starting and open for you the binomial distribution because it takes time. But in these circumstances, I want to have a quick reflection from you about the probability mass function. Can you tell me about what is exactly the meaning of probability mass function?
I think the probability mass function is an average of the probable probability. Like when you take example, throwing a dice, you will have of probability of getting 6, so you have 1 over 6. Probability of getting 4 is 1 over 4. So the average of this will give us the probability mass function.
Can you give us another example for a uniform distribution mass function? Throwing a dice. A coin, yes, sorry. Throwing, spinning a coin. All right? And what is the probability of each face?
Either you will have a tie.
50-50.
Yeah.
So this is another example from the uniform distribution. Thank you very much, and I hope that in this short time we have enough discussion about uniform probability. And for next session, I will continue my lecture through the binomial distribution, that it is very important, and I hope that you will be ready for next session by focusing on some things that I uploaded through to ELE, and you can easily find it. Also, in ELE you can find several examples and several questions about uniform distribution and binomial distribution, and I hope that ELE work and you never seen such as you see here. Thank you so much.
Thank you very much.